This section is on 4.4, which is the least common multiple. So you're going to see some methods that are similar to the greatest common factor, but we don't want to mix up the two. So let's go through some vocabulary. So first, a multiple of a whole number is the product of the number and any non-zero whole numbers. So for example, we could do the multiples of 10 would include 10, 20, 30, 40, and so on. So we're multiplying it by 1, then by 2, then by 3, then by 4. Anytime you do that, you're going to get a multiple of 10. A common multiple is a multiple that's shared by 2 or more numbers and is a common multiple. So if we had 10 and 5, we'd have 10, 20, 30, 40, and let's go up to 50. And here we'd have 5, 10, 15, 20, 25, and so on. So in this case, common multiples would include the 10, the 20, eventually the 30, 40, and 50, because 5 goes into 10. Even though 5 has some of these 5, 15, 25 that don't count, and they're not common. But when we talk about the least common multiple, least being the hint, it's the least common multiple of these 2 or more numbers. So in this case, 10 is our least common multiple because it's a multiple of both 10 and 5. And we also have something called the least common denominator, very similar to least common multiple, but it's the least common multiple of 2 denominators. So if you had a fraction where it was 2 fourths and 3 eighths, you would, when we want to compare these, you'll see later, is we want to find the least common denominator for these two. That way that we can easily compare them. But we'll get into that on a later slide. So the first example is, let's just figure out the 2 methods we have for finding the least common multiple, just like there's 2 methods for finding the greatest common factor. So let's use the situation. If you have 2 alarm clocks set for the same time, because it's really tough for you to get up in the morning, you need 2 alarm clocks to go off to just make sure you get up. And the snooze time on one alarm clock is 10 minutes, and the snooze on the other is 15 minutes. So you're lazy, you want to sleep in a little bit. As soon as they go off, you hit both of their snooze buttons. We want to know, in how many more minutes will both of them ring together? So the first method is to list the multiples of each number and then identify the least number that is on both lists. So for example, like we did before, multiples of 10, because we have the 10 minutes here, and then multiples of 15 here. So we list out until we have at least one in common. So the least common number on this is 30. So we can say it would be 30 minutes before both of those alarm clocks go off together. The alternative way of doing this is finding the common factors of the number first. So 10 is 2 times 5, and 15 is 3 times 5. In this case, just like the greatest common factor would be 5, but when we find the least common multiple, what we're going to do is we multiply what's shared once. So don't use both of these 5s. 5 happens once, because it's shared, times everything that's not shared. So 5 times 2 times 3, 5 times 2 gives us 10, times 3 gives us 30. So we also get 30 minutes. These are the 2 methods for solving the least common multiple. I'm going to make sure that you practice using both, but ultimately it will be up to you for which you feel more comfortable with. So your answer would be the alarm clock will ring together again in 30 minutes. I'll give you a practice problem after the next example. So what if we have a monomial? So now we have these variables included. So if we had 20xy squared and 25xy to the third, how can we find the least common multiple of these two things? The first thing you want to do is write it out as a monomial. So we write 20 is 2 times 2 times 5, and then we have 1x and 2 y's. 25 is 5 times 5 times 1x and 3 y's. And we're going to do the same thing like in the second example in the previous slide. We're going to circle anything that's shared. So here we have the 5x and a y shared. These are only going to be used once. So I like to just cross off the bottom ones. So we're going to multiply all those that are shared once times everything that's outside. So we have a 2, another 2, and another y on the top, and here we have a 5 and 2 more y's. Now this looks like a jumbled mess, but we can simplify this. So this could simplify then to 100xy cubed, because we have 3 y's, 4 y's. Let's see. Yep, this is wrong. This should be to the fourth. 4 y's. 1, 2, 3, 4. 5 times 5 times 2 times 2 is 100, because 5 times 2 is 10, times 10 is 100, and we have the 1x, so we can rewrite it this way. So what I want you to do now is find the least common multiple of either the numbers or the monomials. So the first two are numbers based. The second two, you're going to have to use this technique using the monomials. What I'd like you to do, try method 1 for number 1 and try method 2 for number 2, just to get good practice using both. You might have to rewind to see the two methods if it's not clear in your notebook, and make sure you do make it clear in your notebook how to do each. So press pause now and give it a try. A third example, when I mentioned the LCD earlier, is when you have two fractions that don't have the same denominator. It's really difficult to figure out which one's greater and which one's less. So by using this method of the LCD, it's going to help you compare fractions. So let's use the example of last year, a day spa had 48,000 visitors total, and of those visitors, 18,000 were men. This year, the day spa had over 54,000 visitors, including 24,000 men. And we want to know in which year was the fraction of men greater. So the first step in this type of problem is you need to write the fractions and then simplify them. So 18,000 needs to be simplified with 48,000. How can we make this a simpler fraction? Well, you know you can just cancel out the zeros and then find the greatest common factor of 18 and 48 and divide by that. And that will get you 3/8. The same thing here with the second one. 24,000 and 54,000 is 4/9. But we still don't know if 3/8 or 4/9 is greater, and let's assume you don't have a calculator to check on. So the second step is, can we find the least common denominator of 3/8 and 4/9? Keyword denominator here. We're ignoring the top terms. We just care about the 8 and the 9. I like it. So in this case, we can go 8 is 2 times 2 times 2, 9 is 3 times 3, so nothing is shared. So we have to multiply all of these numbers, or 8 times 9, and the least common denominator is 72. So the next step, it's important to remember each of these steps and to do them in order. We need to write equivalent fractions using the LCD. So just like we did in the previous section, now we need to get the bottom number to be the LCD. So we need it to be 72. In this case, when we have 3/8, 8 times 9 is what gets us 72. So we need to multiply both the top and the bottom by 9, and we get it's 27 over 72. And we do the same thing for 4/9, but in this case, in order to get 9 to be 72, we need to multiply the top and bottom by 8 to get 32 over 72. So now all we have to do is compare the numerators. 27 is less than 32. So we know that 3/8 is less than 4/9. So now we can answer this question, which year? Well, the 4/9 related to this year. So the fraction of men was greater this year than it was last year. So that's an example how you can use this to help you figure out this fraction. Just like you could, if you were comparing a test, which you got, let's say you got 38 out of 40 on your last quiz, and you want to compare it with another quiz that you got, let's say 19 out of 20. You should be able to compare those two to see which is greater or if they're the same. That's just an example of a real life where it might come into play. So the last example is it also can help you order fractions. So not just two, but can we order these from least to greatest? So whenever you're given 3 or more fractions, or even just 2, you want to first write the mixed number as an improper fraction. And I hope you remember how to do this, but just as a little review, if you had 2 and 7/12, you'd multiply the 2 times the 12 first, order of operations, then add the 7 and keep it all over 12. So we'd get 31 over 12. Then we find the least common denominator of 12, 9, and 6. Just like I showed you in the previous slide, I'm not going to show you all the work here because you can use either method, but you find that the LCD is 36. So the least common denominator is, or the least common multiple of these is going to be 36. So now you need to take each one of these fractions above and write it as an equivalent fraction using 36 as the denominator. So in the first case, 31 over 12, in order to get 12 to equal 36, we need to multiply the top and the bottom by 3. So we get 93 over 36. The second one, 24 over 9, we need to multiply 9 by 4 to get 36. So we multiply the top by the same, and we get 96 over 36. And the last one is 13 over 6. We multiply both by 6, because 6 times 6 is 36, to get 78 over 36. And now all we have to do is compare the numerators. So in this case, 96 is the greatest numerator, so that means 24 over 9 is the greatest fraction. Then we have 78 over 36 is the smallest. So we can compare those and then use the original numbers. So we always want to put it back into the original fractions to put them in order. And be careful, you want to check this as least to greatest. Sometimes you might be asked to do it the opposite way. So 13 over 6, then 2 and 7/12. Remember, 2 and 7/12 was our 31/12 that we had here. We want to put it back in the original form, and then 24 over 9. So I'd like you to do, this is it for tonight, but I want you to try to order the numbers from least to greatest here in this example. So follow the steps we did here and work it out on your own and bring it with you to class tomorrow. That's all for today's lesson.